Okay, so we were working with exponential functions. Now we're going to look at logarithmic functions and expressions. So,
I was in the shop, yeah.
So consider the exponential function f of x equals 2 to the x power and its inverse. Recall that you can graph an inverse function by interchanging x and y values. Okay, so remember we can interchange x and y values, okay, in the ordered pairs of a function to get its inverse. So the inverse of y equals 2 to the x can be defined as x equals 2 to the y. Okay? So you switch x and y around. In general, the inverse of y equals b to the x is x equals b to the y. In x equals b to the y power, the variable y is called the logarithm of x. Okay, this is usually written as y equals log base b of x. Okay, so y equals log base b of x. That's what we're going to be looking at today. Now, when we were interchanging, so this is your original function here. Your x value is -3. Okay, to get its inverse, we flip it to the y value. Okay. Again, in our original function here, our y value is 1/8. Okay, we flip it to the x value to get that inverse. So the logarithmic function is the inverse of your exponential function. Okay, so logarithms are inverses of exponential. So we can interchange a logarithmic expression to an exponential expression. So let b and x be positive numbers where b does not equal 1. The logarithm of x with base b is denoted as log base b of x. So you have this little b value as your base, and is defined as the exponent y that makes the equation b to the y power equals x true. So in symbols, you would have log base b of x equals y, if and only if b to the y power equals x. So we can interchange, it's the same exact equation. So to change from a logarithmic expression to an exponential expression, this base b right here, okay, can be canceled out by bringing in this base of b, okay? And whatever I do to one side of my equal sign, I have to do to the other side. So I bring in base b here as well. Now when I do that, it cancels out the b I just added and that log base b, so I'd end up with just x, and that would be equal to b to the y power. Okay, so x equals b to the y power. Okay, so that's how you would interchange between logarithmic and exponential. So you can see that as an example here. So my base in this one is 3. Okay, so to change it into this exponential function here, I would bring in base 3, okay, so to this side, and then whatever I do to one side, I have to do to the other, so bring in base 3 to that side as well. When I do that on the left side, those 3's and that log cancel, so you have 27 is equal to 3 to the y power. Okay, so that's how you can interchange between logarithmic and exponential. So that's what we're going to do in these two examples here. Yep. Because you're bringing in the base. Okay, so since this 3 right here is a base of that log, you have to bring in a base of an exponential. Okay, so I brought in that base of an exponential, bring in this base of an exponential, and you'd raise it to that power then. So we are going to change each equation here into exponential form for 1 and 2. So in number 1, I have a log base 2. So that means I need to bring in a base 2 to both sides of my equation. Can we focus, please? Shh. So I bring in base 2 to the left side and the right side. On the left, it cancels. So I would have 8 is equal to 2 to the third power, which is true. If you want to rewrite it, you could as 2 to the third equals 8.
Isn't that 8 though?
Right. So it's a true expression. We don't have to change anything. We're just changing it into an exponential. So same thing in number 2. We want to change this into an exponential expression. So what is the base that I need to bring into both sides? 4. Okay, so bring in 4, that base of 4 to both sides. It cancels on the left. So you have 1 over 256 is equal to 4 to the negative 4th. And again, we can switch this around if we want, or you can leave it like this. So write it as 4 to the negative 4th equals 1 over 256. Okay, and that would be your exponential expression. So from logarithmic to exponential. Okay, questions on those two problems? Okay, then on the back, we can do just the opposite. So the definition of logarithms can also be used to write exponential equations in logarithmic form. So now we're going to be given, now we're going to be given an exponential form, and we want to write it as logarithmic. So for this one, what I do is locate the base of my exponential function. In this case, that's 15. Since my base is 15, I'm going to bring in a log base 15 to both sides. Okay, so bring in log base 15 to both sides. On the left, that cancels each other out. So you're left with 3 is equal to log base 15 of 3,375. Okay, so you're just changing from exponential to logarithmic. Okay, and in a logarithmic function, you shouldn't have any exponents. Okay, so in an exponential expression, you have exponents. Logarithmic, you don't. Okay, number 4. What's the base in number 4? 4. Okay, so I'm going to bring in a log base 4 to both sides of my equation so that it cancels out that base 4 there. So I have 1/2 is equal to log base 4 of 2. Okay, so we can interchange between exponential and logarithmic. Questions on those two problems? All right, then we are going to evaluate a logarithmic expression. Okay, so make sure you know the difference between the base and the exponent when you're changing. When we evaluate a logarithmic expression, we first want to change it into an exponential expression because we know how to solve those. So if I have log base 16, okay, and I want to change this into an exponential expression first, I need to bring in base 16 to both sides. Okay, that cancels out your 16 and your log base 16. So you're left with 4 is equal to 16 to the y power. Okay, and we solved equations like this before. To solve for that exponent as your variable, you need a common base. Okay, so I can change this 16 to a common base of 4, right? 4 raised to what power is 16? 4 squared. Okay, so this 4 here is raised to the first power. So I can now set both of my exponents equal to each other since I have a common base. Okay, so I have 1 is equal to 2y. Divide by 2. Y will be equal to 1/2. So we can solve this logarithmic expression the same as an exponential. We just first have to change it into that exponential expression. Okay, questions on number 5? Okay, then number 6. Again, we're solving this logarithmic expression. So I'm just going to set it equal to a variable. So it's the same as what we did in number 5. So first thing we want to do is change this into an exponential expression. Okay, so since my base of this log is 3, I'm going to bring in base 3 to both sides of my equation so that I cancel out that logarithm. And I end up with 81 is equal to 3 to the x power. Okay, now my base of 3 I can't really manipulate, but I can this base of 81. Okay, so I need a base of 3 from 81. Okay, 3 to what power is 81? 4. Okay, so 3 to the 4th power is 81. Now that I have that common base of 3, my exponents are equal to each other. So I can say x is then equal to 4. So my expression here, my logarithmic expression, so log base 3 of 81 will be equal to 4. Okay, so I just went back up to my original log base 3 of 81. I found that it equals 4, so I plugged in 4 for x. Okay, questions on number 6 before I do the last one here? Okay, so number 7, we have log base of 1/2 to 256. And again, we want that to equal something. Okay, we want to find what that's equal to. So again, first I want to change this into an exponential expression. So I'm going to bring in a base of 1/2. Okay, cancels out the logarithm. So I have 256 is equal to 1/2 to the x power. Okay, I don't want to keep it as 1/2 though. I want to change that into a whole number base.
You have to?
Yeah. What can I change 1/2 to?
0.5.
No,
5.
a whole number.
Plus
How do I change it and change that exponent if it's a fraction? No. Change. Shh. No, not multiplying.
Add half.
You want to change it to a whole number with what type of exponent? A negative exponent. Okay, negative exponents, flip it to the denominator. So what would your base be? 2. Okay, to the negative first power is 1/2. Okay, that means I want a base 2 of this 256. So I have to see 2 to what power gives me 256.
12. 11? 14. It's 14.
13.
No.
12.
No.
9. 8.
8. Okay, if you don't know, plug it into your calculator. Okay, try to the 5th. Okay, try to the 6th, to the 7th, to the 8th.
That's wasting time.
Okay,
Yeah, that's wasting my precious time.
you don't even do your assignment in the first place. Okay, so from here, now that I have a common base, okay, my exponents are equal. So I have 8 is equal to negative 1x. Okay, divide by negative 1. Okay, and that x value will equal negative 8. So I can say log base 1/2 of 256 is equal to negative 8. Okay, so that logarithm is equal to negative 8. Okay, so again, if you see a fraction, that means you're going to change the base, okay, and you'll have a negative exponent. See a fraction, you need a negative exponent.
Your test.
Got it?